Hello everyone, for this tutorial video, I'd like to explain how you can figure out 2D planes in 3 dimensions in terms of an equation for them. In particular, we will choose an arbitrary point on the plane and denote it with a vector, and next take a vector that is perpendicular to it, which is more technically called a normal vector, and we next take another arbitrary point on the plane, take the difference between the two vectors representing these 2 points, and see, because the normal vector is perpendicular to the plane itself, it will be perpendicular to any line on the plane, so it will be perpendicular to what we just derived, the difference of the 2 positions. We next see the dot product, which is the nickname for the multiplication of each individual component as they appear, and then the total sum of that. We see, if we assume the normal vector has a component of 1 for all 3 of its components, then it should follow the dot product of the normal vector and the vector difference of the 2 positions equals 0. And we can actually write this as normal vector times final position equals normal vector times initial position. And this is called the vector equation of a plane. If we instead painstakingly write out all of the components of all the vectors, we would see the components of the difference is simply the difference of the individual components, so we simplify it like that, and see by the definition of the dot product. A times difference in x plus b times difference in y plus c times difference in z equals 0. And the equation of this, with all the components individually, is called the scalar equation of a plane, because it uses scalar numbers, or numbers with only quantities and not directions, instead of the vectors. Now that we have figured out how to derive special equations for lines and planes in 3D space, we can next move on to describing functions that give an output of z for an input of x and y at the same time, aka multivariable functions. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.